Hello, class. We are on the third lesson out of 4 that we will do this week. I hope that you are doing well and enjoying the geometry. Today on section 10.3, we will discuss how to find the areas of parallelograms and trapezoids. So what I have done is I've created a little parallelogram here. Grab some scissors. And the cool thing with the parallelogram is you could see the height. This is not the height of the parallelogram. The height is from the top to the bottom bases straight down. So the height always has to be at a right angle somewhere. So you could take that measurement or this measurement here. Okay, so this is the height of our parallelogram. And of course, this would be our base, this length here. And here's a clever little trick. If we were to cut off this part of our parallelogram and move it over here, well, it probably wasn't a perfect parallelogram. I just freehand cut it. But anyways, we can always create a rectangle out of a parallelogram. Every single parallelogram, if it's truly a parallelogram, can become a rectangle. And the area of a rectangle is the base times the height, correct? So easy enough. That is the formula for the area of a parallelogram. Base times height. The base again, these bases, it doesn't matter which one you use because they're the same, but the height is straight up and down. So let me clue you into a trick. Every geometry student has been tricked in this way. If you have given a picture like this, where this length of side is 8, let's say, the base is 10 and the height is 7, there's one number here that has nothing to do with the area. And you can see this is the number here. We don't care how long this side is here. So the trick is pay no attention to that number. If it is given, you only want to know the base times the height. So the area of this parallelogram would just be 10 times 7 or 70, and then whatever your units are squared. Easy enough. All right, let's take a look at trapezoids. So I've sketched a little trapezoid here. Remember, in trapezoids, you have exactly 2 parallel sides. We call one of these the base sub 1, one base, and the other is base sub 2. Okay, we've got 2 bases. Notice that they're different lengths, correct? But we still can find the height. The distance between 2 parallel lines is always the same. So 2.5 would be the height of this trapezoid. And now this, to me anyways, makes sense. Instead of choosing like, well, which base would you use? Like with a parallelogram, it's just base times height. What do you do when you've got 2 different bases? I don't know, seems to make sense to me. How about if we average those 2 bases? So the base 1 plus base 2 divided by 2, you're finding the average of those 2 numbers, and then you take that and multiply by the height. That's how I remember this trapezoid formula. I hope that makes sense to you too. Sometimes you can see this formula rewritten like this. They just pulled the 1/2 out front. You've got your b sub 1 plus b sub 2 times h. Now these are what we mathematicians call plug and chug. Once you've got a formula, you just plug in the numbers and then you chug out the arithmetic. So let's find the area of this trapezoid. Area is equal to base 1 plus base 2 divided by 2. So I've got 4 plus 9 divided by 2. I'm finding the average of the bases. I'm going to multiply that by the height, which is 2.5. Now at this point, I probably want to grab my calculator. Handy dandy. 4 plus 9 is 13. 13, I don't know if you can see that. There we go, that's a little bit better. Divided by 2 times 2.5 the height, and we would get an area of 16.25. And remember, area is always square units. Square units. Alrighty, there is a checkpoint in your book on page 548 at the bottom. Page 548. Why don't you pause the video right here and try them? They're pretty quick. Grab a calculator and try them and meet me right back here. All right, and I will just show you the answers to those. The area of the parallelogram, 5 times 6 or 30 square feet. For the trapezoid, you should have gotten 51 square meters. And for number 3, should be 280 square inches. Alrighty. One thing to note here, just like the trick in the parallelogram, notice that you do not need to know these sides. These sides have nothing to do in this formula, only the bases and the height. Okay, sounds good. Let's go on to example 3, which is on the top of page 549. It says, the height of a trapezoid is 6 meters. So I'm going to write that out. My height is 6. One of its bases is 8 meters. So one of the bases is 8. And the area of the trapezoid is 54 square meters. Find the other base. This method that I'm using is very, very good to use right through calculus. You will always be trying to solve problems in math. It's very good if you write down, what do we know? What are we trying to find? And of course, the formula that we're going to use is right up here. A is equal to, and you can write it either way. I'm going to flip and do it the other way just for fun. B sub 1 plus B sub 2 times H. Now let's fill everything in where it goes. So we would have 54 is equal to 1/2. B sub 1 is 8 plus, whoops, I don't need that comma. B sub 2 is what we're trying to find, and H is 6. All right, now how do we solve this? Well, this is just a little bit tricky. A couple of things you could do. You could divide both sides by 1/2. That's the same as multiplying by 2. You could divide both sides by 6. Or you could combine these two guys. 1/2 of 6, that's 3. We could multiply this through, but it's actually easiest at this point to just divide both sides by 3. And 54 divided by 3, I should know that. 54 divided by 3 is 18. So 18 is equal to, these guys cancel, 8 plus B sub 2. What do we do next? Subtract the 8. So we have found that the second base must be 10, and that was meters. So we should put the units in there. 10 meters is equal to the second base. That would give us a trapezoid with area 54. So that wasn't a very long lesson, but you'll see that the problems, I gave you some challenging ones. So I hope that you are diligent and persevere and have fun. And I will see you next time.